The ninth step is category of affine schemes. So let's delve deeper into the category of affine schemes. In the category of affine schemes, the objects are affine schemes themselves. Each affine scheme is associated with a commutative ring, and the points of the affine scheme correspond to the prime ideals of the ring. The morphisms in this category are functions that preserve the structure of the affine schemes. These are functions that are continuous with respect to the Zariski topology, and that commute with the structure sheaves of the affine schemes. Like any category, the category of affine schemes has a composition operation and an identity morphism for each object. The composition of two morphisms is just the composition of the corresponding functions. This means that if you have a morphism from one affine scheme to a second, and another morphism from the second to a third, you can combine them to get a morphism from the first to the third. The identity morphism for an affine scheme is the identity function on the set of points of the scheme. This function takes each point to itself and preserves the structure of the scheme. There is a deep connection between the category of affine schemes and the category of commutative rings. These two categories are anti-equivalent, which means that they are essentially the same category, but with the arrows reversed. This anti-equivalence is given by taking the spectrum of a ring to get an affine scheme, and taking the global sections of an affine scheme to get a ring. This connection allows us to translate problems and concepts from one category to the other, which can often simplify our work. The category of affine schemes plays a central role in algebraic geometry. It provides a framework for studying the relationships between different affine schemes and their morphisms. It also serves as the foundation for the more general theory of schemes, which are geometric objects that can be glued together from affine schemes. By working in the category of affine schemes, algebraic geometers can use the powerful tools of category theory to study the properties and relationships of these important geometric objects. In the context of the category of affine schemes, we often consider functors and natural transformations. A functor is a map between categories that preserves the structure of the categories, and a natural transformation is a way of transforming one functor into another. These concepts allow us to study the category of affine schemes in a more abstract and general way. In summary, the category of affine schemes is a mathematical structure that organizes affine schemes and their morphisms in a way that makes their properties and relationships easier to study. It is a fundamental tool in algebraic geometry, and it provides a bridge between the geometric world of schemes and the algebraic world of rings.